Welcome to your second flip video. This is 2.0b Exponent Operations. Rule 1, multiplying exponents. Make sure you have this next to the red line on the left side of your paper. When we multiply exponents, we're thinking of x cubed, this is just an example, times x to the fourth. Now, if you're going to write that in expanded form, you already know that you would write x 3 times x times x. And then you're still multiplying by this x to the fourth. So we actually add 4 more x's when we're multiplying. Now you see that there are 1, 2, 3, 4, 5, 6, 7 x's. So what we're proving here is that if we have x to the third times x to the fourth, we actually can say x to the 3 plus 4 equals x to the 7th. So now we've simplified the expression, and we didn't have to write an expanded form like we did here. So the rule is that if you have two of the same bases with different exponents or the same exponents that are being multiplied together, you can add them, add the exponents, and you eventually get x to the 7th power. So this is the simplifying rule for multiplying exponents. Here's an example of multiplying exponents. Now, you see here that we have two different bases. The first step underneath this to simplify the expression is that we combine the bases that are the same. So this is all multiplication. You already know that. And I'm going to rewrite this underneath. K to the third times k to the fourth. I'm going to put that in parentheses because I want those two together, since I know I can combine those exponents. And then, since the parentheses are next to each other, we're still just multiplying. This is g squared times g to the fifth. Now, according to the rule of multiplying exponents, we now can do 3 plus 4 to know what the new exponent of k is. So k, now 3 plus 4 is 7. G squared times g to the fifth is the same as g to the 2 plus 5. So our answer here, is g to the 7th as well. Now we have simplified the expression. Our next rule goes along with dividing exponents. And if you're thinking in your brain, okay, multiplication of exponents, I add the two exponents. I wonder what I do when I divide the two exponents. If you're starting to think of the opposite operation, you are on the right track. So, x to the fourth divided by x to the third. So, our goal here is to simplify. So the directions will say simplify this expression. First thing I'm going to do is write this in expanded form. So the numerator has x times x times x times x over x times x times x. So all I did there was just expanded this so that I have the whole thing written together. Now, you know that if two things are the same in the numerator and the denominator, they can cancel each other out. So these two x's cancel out, these two x's cancel out, these two x's cancel out, and all we're left with is x. Okay? So that means the rule is that if we have x to the fourth divided by x to the third, this is the same as x to the 4 minus 3 power. 4 minus 3 is x to the first, And you know from our rules from last video that anything to the first power is just itself. So what we just proved is that when we're dividing exponents with the same base, we can just subtract. So 4 minus 3 is 1. We simplify even further and we get x. Okay, now let's go ahead and look at example here. Notice that the z and the z are not right on top of each other. The m and the m are not right on top of each other. This is mixed up. Our job today is to simplify this expression. So the first thing we're going to do is split it up into z's and m's. So underneath you would write z to the 7th over the other z that's in the denominator is z to the 2nd. I'm going to go ahead and put this in parentheses since I want them to be together now. And then I'm multiplying m to the 3rd, which is in the numerator, over m to the 2nd. Now, you know that z to the 7th and z to the 2nd have the same base, and our rule told us that if we have the same base, we can subtract the exponents when we're trying to divide two exponents. So, z to the 7th and z to the 2nd, 7 minus 2 is 5, so this becomes z to the 5th, m to the 3rd, and m to the 2nd. We know that since our bases are the same, we are dividing these two exponents. We can do 3 minus 2. 3 minus 2 is 1. So now my new exponent is 1. Now just like last time, remember we're not in simplest terms if we have an exponent of 1. So we now have z to the 5th times m. And that's it. Our last rule today, Rule 3, is called raising to a power. Now, raising to a power means that we have an exponent that we're raising to another exponent. And what that looks like would be a variable with already an exponent in parentheses being raised to another power. So let's go ahead and prove this. If I have x to the 3rd squared, that means I have x to the 3rd times x to the 3rd. Now I'm going to keep writing this out in expanded form, just like we've done in the past two rules. So there are 1, 2, 3 x's times 1, 2, 3 x's. That's what expanded form looks like. So since there are 1, 2, 3, 4, 5, 6 x's now, that's really the same as saying x to the 6th. Now, that was a lot of work that we just did, so I'm going to show you the rule here. And if you've already seen it and you've figured out the pattern, good for you. Let's go ahead and look at it again. X to the 3rd, in parentheses, raised to the power of 2, is the same as x to the 3rd times 2. And you saw that up here because we wrote x to the 3rd twice. We wrote 1, 2, 3, 4, 5, 6 x's, so this became x to the 6th. If we would have just done 3 times 2 here, we would automatically get 6. So our new power is x to the 6th. Our next example, we are raising to a power here. This is the quantity of 7 to the 4th times y to the 3rd raised to the 3rd power. And notice the way I'm saying raised to the 3rd power. When we're talking about a quantity with an exponent, we say raised to the blank power. So this is raised to the 3rd power. Now to solve this, we're going to separate it out just like last time. 7 to the 4th is going to get its own parentheses. Now this is raised to the 3rd power times y to the 3rd gets its own parentheses, and it's also raised to the 3rd power. Now, according to our rule of raising to a power, instead of writing out in expanded form all these z's to the 4th and then writing them out again, we know that we can do 4 times 3 to get our new power. So when we're raising to a power, we just multiply by what's on the outside. So this becomes 7 to the 12th, y to the 3rd, raised to the power of 3, becomes y to the 9th. Now, we know that since we're in algebra, we actually don't have to write that multiplication sign between them, because we know when things sit close to each other, that means multiply. Now we are finished. Good job.